Welcome to an intro to systems of ODEs. So the general idea is there are many physical scenarios that cannot be modeled by a single differential equation. And sometimes we will have multiple equations and multiple dependent variables. We are going to focus on the two scenarios we've already looked at, so namely mixing and spring mass systems, but we're now going to deal with two tanks, and when we switch to spring mass systems, we'll deal with two springs and two masses. So let's go ahead and take a look at a mixing example with two tanks. So we have a system of two 1,000-gallon tanks. Tank 1 initially holds 200 gallons of solution containing 20 pounds of salt. Tank 2 initially holds 400 gallons of solution containing 80 pounds of salt. A solution with 0.3 pounds of salt per gallon is being added to tank 1 at a rate of 3 gallons per minute. And a solution with 0.5 pounds of salt per gallon is being added to tank 2 at a rate of 4 gallons per minute. Solution is being pumped from tank 1 to tank 2, so pulled out of tank 1, transferred to tank 2 at a rate of 2 gallons per minute. And at the same time, solution is being pumped from tank 2 into tank 1 at a rate of 3 gallons per minute. Tank 1 is draining at a rate of 2 gallons per minute. Tank 2 is also draining at a rate of 2 gallons per minute. Our job is to write an IVP modeling the quantity of salt, pounds of salt, in each tank at time t. So our setup's a little more complicated than we've had before. We have two tanks. Tank 1 and tank 2. We have water being added to tank 1 at 3 gallons per minute. And that's a solution, which is 0.3 pounds of salt per gallon. Then we have water transferring through a pipe, leaving tank 1, going into tank 2. This is leaving at 2 gallons per minute. We have another pipe, which is pulling from tank 2 into tank 1 at 3 gallons per minute. We have a solution going into tank 2 at 4 gallons per minute. And that solution had 0.5 pounds per gallon. Then we have draining out of each tank, both at a rate of 2 gallons per minute. So essentially each tank has 2 sources adding and 2 sources draining the given tank. So we'll call the volume in tank 1 V1, and it'll depend on time. Volume in tank 2 will be V2, depending on time. The concentration will be quantity 1 of T over V1. So let's say the concentration in tank 1, quantity in tank 1 in pounds. Quantity of salt, sorry, in pounds. In tank 1 will be Q1 of T. And in tank 2 will be Q2 of T. Now we could see the concentration of salt for tank 1 will be Q1 of T over V1 of T, pounds per gallon. The concentration in tank 2 will be Q2 of T over V2 of T. So let's first just figure out V1 and V2. So volume for tank 1, we have an initial volume of, I believe, 200 gallons. Yes, so tank 1 initially holds 200 gallons. So we have an initial volume of 200 gallons. We add 3 gallons per minute. Let me update my screen. We add 3 gallons per minute from the external solution. And we add another 2 gallons per minute from tank 2. And then, so we add a total of plus 5 gallons per minute. Sorry, we gain 3 gallons per minute from tank 2 for a total of 6 gallons per minute. Then we lose 2 gallons per minute to tank 2. And we lose an additional 2 gallons per minute just from draining. So in total, we lose 4 gallons per minute. So we have V1 prime should be equal to 6 minus 4, otherwise known as 2. V1 of T is therefore 2T plus our initial condition. So we get V1 of T is 2T plus 200. For tank 2, we have an initial volume of 400 gallons. We add 4 gallons per minute from the external source. We also add 2 gallons per minute from tank 1. So in total, we add another 6 gallons per minute to tank 2. We lose 3 gallons per minute to tank 1. And we lose 2 gallons per minute from draining. So we lose a total of 5 gallons per minute. So we have V2 prime should be equal to, we add in 6, subtract off 5, or just 1. V2 of T is therefore just T plus the initial volume. And in this case, that's T plus 400. So we have our volume equations. Then we can do our rate of change of the quantity. So now let's do our rate of change. Pounds of salt. So for tank 1, for our rate in, we have 2 things coming in. We have 0.3 pounds per gallon at 3 gallons per minute. And we have an additional, whatever the concentration is in tank 2 at 3 gallons per minute. So we have 0.3 pounds per gallon times 3 gallons per minute plus our concentration in tank 2 was Q2 of T divided by V2 of T pounds per gallon, again times 3 gallons per minute. So we get 0.9 plus 3 over V2 of T was T plus 400 times Q, times Q2. So this was our rate in. Our rate out we are losing 2 gallons per minute out of the bottom, and we are losing 2 gallons per minute to tank 2, all of whatever solution is in tank 1. So we lose Q1 of T over V1 of T times 2 gallons per minute to tank 2. And then we lose another Q1 of T, V1 of T over V1 of T time, this is pounds per gallon. So Q1 of T over V1 of T pounds per gallon times 2 gallons per minute to draining. And so this is just 4 over V1, so 4 over T plus 2T plus 200 times Q1. So if we get that Q1 prime is rate in minus rate out, we have that Q1 prime is 0.9 plus 3 over T plus 400 times Q1 minus 4 over 2T plus 200. Sorry, that first one should have been 3 over T plus 400 times Q2, and then minus 4 over 2T plus 200 times Q1. So the rate of change of pounds of salt in tank 1 depends on both the amount of salt in tank 1 and the amount of salt in tank 2, as well as time. For tank 2, for rate in, we are adding 4 gallons per minute of 0.5 pounds per gallon. So we have 0.5 pounds per gallon times 4 gallons per minute. Plus from tank 1, we are adding Q1 over V1 pounds per gallon at a rate of 2 gallons per minute. So our rate in, we are looking at 2 plus 2 over V1, which was 2T plus 200 times Q1. For our rate out, the tank 2 is losing 3 gallons per minute to tank 1, and it's draining out another 2 gallons per minute. So we have tank 2 has a concentration of Q2 over V2 times 3 gallons per minute to tank 1. And then we have, again, concentration Q2 over V2 times 2 gallons per minute to draining. And so this would give us 5 over V2, which was T plus 400 times Q2. So we get that Q2 prime is equal to, we do rate in minus rate out. So we have Q2 prime is equal to 2 plus 2 over 2T plus 200 times Q1 minus 5 over T plus 400 times Q2. So we now have our system becomes Q1 prime is equal to 0.9 plus 3 over T plus 400 times Q2 minus 4 over 2T plus 200 times Q1. I'm just going to check I remembered that one correctly. Yes. And then our second equation is that Q2 prime is equal to 2 plus 2 over 2T plus 200 times Q1 minus 5 over T plus 400 times Q2. So we have not solved anything at this point. We have just set up our system. And then we have initial conditions. Our initial conditions, our initial quantity of salt in tank 1 was 20 pounds. Our initial quantity of salt in tank 2 was maybe 80 pounds, but let's just check that. I apologize for the scrolling. So we had initially, tank 1 initially contained 20 pounds. Tank 2 initially contained 80 pounds. So we have Q2 of 0 is 80. So this is our system and IVP. All put together is this Q1 prime equaling 0.9 plus 3 over t plus 400 times Q2 minus 4 over 2t plus 200 times Q1. With the second equation, Q2 prime equaling 2 plus 2 over 2t plus 200 times Q1 minus 5 over t plus 400 times Q2. With our initial conditions, Q1 of 0 equals 20 and Q2 of 0 equals 80. So this is how we can set up a mixing problem involving two tanks with liquid flowing between the tanks, coming in separately and draining as well. In the next video, we will look at a spring mass system where we have two spring mass systems sort of attached on end.